Here in question number 11, two particles of equal mass have velocities 2 meter per second and 2 meter per second respectively. First particle has a uniform acceleration of I plus j meter per second square, while the acceleration of second particle is 0. Trajectory of the center of mass of the two particle system is. We need to find the initial velocity of center of mass and initial acceleration of center of mass. That will give us the way the particle will be moving. So velocity of center of mass, it would be m1 v1, that is m2I plus m2j divided by 2m. So it is I plus j meter per second, that is the velocity of center of mass. Now the acceleration of center of mass is m1a1, m a being 0 plus m here, I plus j divided by 2m. So we are getting the value here to be equal to I plus j divided by 2. This is the acceleration of center of mass at the initial state. Now what we see here, the velocity and the acceleration are in same direction. So just by looking into this part only, we are confirmed that the center of mass will be moving in a straight line. So for question number 11, option 4 is the correct answer. Now we shall proceed to question number 12. Here in question number 12, moment of inertia of a uniform semicircular disk mass m radius r about an axis passing through O and perpendicular to the plane of the disk. If we assume the complete disk of mass this side m and this side m, then we shall have the moment of inertia about this point would be how much? Total mass 2m r square divided by 2. Is that? So it must be the sum of moment of inertia of this part and this part. So we shall simply say the moment of inertia of this side would be, if it is I, it will be taken as 2I, or I would say m r square divided by 2 is the moment of inertia of the given disk here. So for question number 12, our option 4 is the correct answer. Now we shall proceed to next question. Here in question number 13, a ball is dropped from a height of 100 meter and simultaneously another ball is thrown from the ground with a speed u vertically upward along the same vertical line. If collision takes place at height of 20 meter from ground between these two balls, then value of u is. It's been given that the initial velocity of this particle was u along the direction and it was having 0 velocity. So relative velocity of this particle with respect to this one is already u, and it's been already said that the collision takes place at a height of 20 meter from ground. So first we need to calculate the time at which the collision will be taking place. Let it be t. I would say the distance relative how much it was, 100 meter divided by u. This is the time at which the collision will be taking place. Now this distance being how much, 100, and here it is 20. So definitely this distance will be 80 meter. So this particle must have fallen through a depth of 80 meter in this much of the time. So I would say 1 by 2, g is this much, 10, t square, this is 100 into 100 divided by u square, it must be equal to 80. Evaluate this part and we shall be getting the value of u to be equal to 25 meter per second. That's the answer for question number 13. Option 3 is the correct answer. Now we shall proceed to question number 14. Here in question number 14, an object has velocity 25 by 4 meter per second at time t is equal to 0. The body deaccelerate at a rate given by minus dv dt is equal to k root v. If object comes to rest at t is equal to 2 seconds, then value of positive constant k in SI unit will be equal to. It's been said initial velocity to be equal to 25 by 4 meter per second, and dv dt was given to minus k v to the power 1 by 2. Integrate this function and we will have dv v to the power 1 by 2 must be equal to minus of k dt, or this portion is root v 2 at t is equal to 0, the velocity was v naught. Finally it becomes how much? 0. So it is minus k into time t was how much? 2 seconds. So this part is coming out to be 2 root v naught is equal to 2 into k. So k is how much? It is coming out to be root v naught. K is equal to, that is 5 divided by 2. That is the answer in SI unit. So our option 2 is the correct answer for question number 14. Now let's proceed to question number 15. Here in question number 15, a particle is projected from an inclined plane with the speed u. If maximum range along the inclined plane is 20 meter, then value of u is. If you go for the condition of maximum range here, we'll be getting this value r max to be equal to u square divided by g 1 minus sine of theta, theta being 30 degree here. And it's been given to be how much it is? 20 meter. So I would simply say u square divide by 10, 1 minus sine 30, it is coming out to be 1 by 2, that's given to be how much? 20, or u square is equal to 10 into 1 by 2 into 20, or u is equal to 10 meter per second. That's the answer for question number 15. Option 3 is the correct answer. Now we shall proceed to next question, that is question number 16.